Okay, after wait, I'm going to talk about AWS and SilverStripe. But first, a bit about Twisted Bytes. I think a few people here know who I am. But Twisted Bytes is a hosting service company. I help companies with their hosting. That's mostly setting up, maintaining, and monitoring servers. Services and infrastructures. I'm based here in Enschede, and well, you can reach me or the company at these addresses. About me, originally I am a developer, but I sort of became a system administrator. And my system administration is mostly with Linux, and I maintain and service and infrastructure, just what I said just now. And why that's maybe important is that I am a system administrator that sort of understands developers. I know there's a lot of system administrators walking around that don't understand developers, they just know how to set up a Plesk or something like that. I'm not like that. I try to sort of know what developers want, and I'm open for whatever developers tell me, so I can help them better keep their systems online and that kind of stuff. I'm going to talk about these things, a bit about AWS, a bit about how to run SilverStripe on AWS, how to deploy it all. I'm going to do a demo. That was the whole point, that I needed my laptop, and a bit about the costs of the whole thing I've set up, and some pros and cons of this. So, what is AWS? AWS is worldwide collection of services, and one of the most important for this talk is that it helps scaling, makes scaling easy with multiple servers with their tools. They've got lots of services, and most of them run on servers, but AWS is segmented in regions and AZs. A region is a location somewhere on the planet, like in Europe there are 4 regions right now, one in Stockholm going online in 2018. And an AZ is part of a region. Each region has multiple AZs. The reason for that is that you can see them as separate data centers, but they are sort of connected, and when you set up services in AWS, you set them up in when you're going to do it high available, you're going to set them up in multiple AZs in a region, and it's possible to use multiple regions which will get you more reliability all over the world. So that's sort of what AWS is. It's a worldwide collection of services. This is a list of some of the services. I think anybody who's ever logged into AWS knows this list, and maybe decided from, well, that's not for me. But it's a lot, and this is, I think, only 50% of it, and each year they're adding more and more. So why do you want to use AWS? One of the reasons I've started this whole journey is because it promises to make scaling and high availability easy. They do this by some services where you can create and add servers automatically based on the load of those servers. And one of the things that what makes it possible to use this for SilverStripe is that they have shared resources, like a file system that you can use between multiple servers, which is very useful for, say, the assets. And you've got databases that are managed and high availability, and they cannot go down. Everything can go down, but it's a better way than do it by yourself. The reason to use this on AWS and not on something else is that getting especially the shared file system and databases on normal servers is a lot harder than when using them from AWS. And when running on AWS, you get easier access to all those tools AWS is giving. And it can be a lot. There's the text-to-speech engine Alexa is using. There's video recoding as a server. There's Elasticsearch as a server. Most of the things you can think of AWS has already thought of. So how can we scale SilverStripe with AWS? Well, it's rather simple. You have to create some servers, you have to create a database, you have to create a load balancer and shared file system for your assets, and then you're done. So that was my talk. Well, no. I'm going to walk you through what you have to create, because maybe some of you know how much work it is to create the whole thing, but I sort of want to make it clear how much work it is to create something. But these are the main things you have to create in AWS. In AWS, you sort of create the whole thing from scratch. You only get a blank paper and then you have to build it all up. But we first start with the networks, and in each AZ, you have to create your networks. And it's good practice to have your public and private services separated. So you have to create 2 networks in each AZ. And then you have to add some stuff like gateways, firewalls, and routers. When you have got your network online, you can add some servers. Those servers are simple servers, only in OS, so you have to install them from scratch. There's a possibility to use templates, but be sure what templates you use, because there can be anything on it. And where's the fun in using templates? So, you create your servers, and the main thing you have to install is of course your web server, PHP, and directory structure for SilverStripe. Next you need a database. Don't install the databases on the server you just created, because then it's a single point of failure. Or you have to create a database running on multiple nodes, and well, those are hard. After that, you've got your servers in your database, and you need some traffic to those servers. You need a load balancer. The load balancer is sort of a simple device. It gets traffic and it sends it to the servers. But of course you have to configure it, and the more servers you have, the more settings you have to fill in to the load balancer. Okay, but we'll create it, and of course we have to add the certificate there. The last one is NFS, which is the shared file system. In AWS speak, it's called EFS. It was added, I think, a year ago, maybe 2 years ago, but it was the final thing I sort of needed to have something as a SilverStripe running on AWS. Otherwise, you have to set up your own NFS server, and what I said earlier, it's hard to have an NFS server running in high availability mode or setup. Okay, we got it all running, and now the servers are getting some traffic and they get more busy. And you need to add servers. Now you have to think of, how did I create those first servers? And of course you made those by hand. So, but the server is getting busier and busier, and creating a new server is, I don't know, 30 minutes. So we need something that can automatically make those servers. And of course AWS has a solution for that, and it's called an Autoscaling group. With it you can add servers and remove servers based on how busy those servers you already got in the group, how busy they are. And when they get too busy, a signal is sent, and the Autoscaling group catches that signal and starts to build a new server and going to add it to the group. And when it's online, the load goes down, because the request will be split over all the servers. But this sort of means that you do not create your own server. So AWS has to create your server. So you have to define how you create your servers, and how you install all the software, and how you connect the file system, and put your code on it. So it's a whole different thing. So we have to change some things. And mostly we have to change everything we just created, because everything has to be defined instead of created. AWS has to know what you want. One of the most important things, of course, is how do you create those servers. What I've done is created a Puppet setup that is run the first time the server starts up. There's tools for giving a script for a starting server, and this will install the whole server with everything you need. But be sure that it doesn't take too long. If it takes too long, the autoscale manager thing will kill the server you just started, because it takes too long to service requests, and then it's going to start a new server to do the whole thing again. And each server you start, you're at least pay 1 hour. And if you're going to in a loop there, it's going to cost you. But in the end, I got it down to 1 minute after it says you need a new server. It adds a server and it's up and running. So how do we all create this stuff? The setup I'm running right now has 70 things to configure, and most of those are interconnected. So you create something, and then you have to copy-paste some IDs from one place to another place. So it's no way you can do it by hand. Or you can do it by hand, but you're going to make some errors, and you're not going to find the errors, probably. So use a tool, and the tool I recommend to use is Terraform. That's sort of the only thing I will say, use Terraform for something like this. I've created an all-in-one Git repo. I wanted to have it online, but didn't get to it. But I will send it in the Slack or tell you somewhere. In the repo, there's a SilverStripe 4 project. There's a Vagrant, so you can develop your website locally. I've got got a buddy configuration. I've got, I think I missed something. No. The Terraform configuration and CodeDeploy scripts. I haven't talked about CodeDeploy scripts, but they're in there. There's a demo, so let's do a demo. I got a site. Here it is. It's not the most beautiful site, and I was telling you about a certificate. Okay, there's a certificate, I think. It's a default site, nothing special. What you're seeing here is just a SilverStripe demo thing. What you see here, I've added something in the templates with a host name. The IP thing is the host name of the server this one is running on. And of course, I told you a bit about Terraform, and we want to have multiple servers. At this moment, we're running only one server. This is the server you're running. It's an EC2, it's an instance, it's this server, and here, you see the IP number, you see here. So we want a new server, and of course, we're going to do it with Terraform, because I just said you should. I'm changing two numbers, which is the minimum. This is part of the configuration of the Autoscaling group. This is the minimum size and the desired capacity. So this is part of the Terraform configuration. And now I'm going to do a Terraform apply. I hope this works. What Terraform does is I've sort of defined how my infrastructure should look like, and Terraform sort of compiles it to all kinds of API calls, send those API calls to Amazon, and at the moment it saw that there's a difference between my local configuration and the thing running on AWS. So now here you see there's a difference in the desired capacity and the minimum size. So I say yes. I haven't showed you, but it's so this is the configuration of the Autoscaling group. I don't know where the screen is smaller than normally. Here's an Autoscaling group thing, and here are those numbers, what I just filled in. There's a possibility, of course, to edit it, but I did it some other way. Here you see that at just a few seconds ago, I think, something happened with AWS. It detected that the minimum and the desired capacity is not equal to what it is at the moment. You see here, there's instances too, and the desired is 2, so it will create a new server. And you see here, it's not in servers yet. Now we'll look at the instances where there was only one just a minute ago, and now there's 2. The only thing I did was change those variables, and they did a Terraform apply, and now it's creating the server. We see here that it's a new IP, and one of the things what's maybe interesting is I was talking about availability zones. Here's availability zone EU West 1. B and one A. So those are two different data centers, I think somewhere in Dublin. Okay, now it's creating, still initializing. I'm going to start a new, I think it's already online. So, but mind, this is here is 1029, and we're going to open it again in a thing. Okay, it's still on the old server. New screen. 101.6.8. So this is the new server. It's running. Well, this is about it. But we also want, of course, we want to change something in the code. I hope this works. I missed a part. I'm sure I missed a part in the presentation. Here. It's probably the easiest way to get something changed. I'll add just some things. Okay, I changed something. Now I need to commit it. Hope this works. I haven't tried it. So, okay. Now we're at Buddy. I think I should go back before going on, because I think I missed a part of the presentation with all the things. Yeah, I think I deleted some slides. There's a part of how to deploy the whole thing, which is called CodeDeploy. Because you don't, with creating all those servers without human intervention and AWS creating servers and deleting servers whenever it thinks it needs them, you don't know your servers anymore. There's not an IP number you can log in and deploy it anywhere. So you need something in the middle between your code and your servers to install, to install your application. It's called CodeDeploy. What you do with CodeDeploy is you create a zip file. With a zip file with your code and some scripts for AWS, because AWS has to know how to install those files into the server. And the scripts run on special hooks. Say before install you want to shut down PHP. After install you want to run dev build, and then you want to restart the PHP again. These are scripts, and that's all in the zip file. What you do is you upload the zip file to S3, and then you give CodeDeploy a signal, please deploy this zip file in this Autoscaling group. With that, CodeDeploy starts its work, sends a zip file to all the servers, and all the servers start running the scripts, and after a while it has updated all those servers. This also means that all your developers need some access to AWS, because they have to send an AWS API call. And access management in AWS is a lot of work. So if you can keep as many people out of AWS, that's good. Plus, Buddy is an awesome product, and it's a sponsor, so please do use Buddy for stuff like this. If you haven't seen Buddy yet, this is Buddy. What you do is have pipelines. It's a sort of a CI pipeline thing. And this is what you configure. There's, and I've only got 2 steps in this whole thing. It's, this step is install Composer, maybe do some NPM stuff in Buddy, so you don't have to have Node.js running on your servers. Please don't have please don't have Node.js for compiling stuff on your servers. Well, do whatever you need to do, and to make it ready to put it in a zip file. And here you say the whole / directory needs to be zipped in a file, sent to this account,
And in this application, the CodeDeploy thing that was configured in AWS is named sample app. Some configuration, etc. I'll cancel it. I think it's, when you run, say, run pipeline, this is my typo, so probably is what I just committed. So I do a run now, and it's going to do whatever was said there. So it's doing a composer install here. Well, it does. It did its things, and now it's uploading oh no, now it's creating the zip file. It just uploaded here. It's uploaded, loading the thing to S3, and this is the API call. I hope there's no sensitive information in there. But now it's in S3, and I hope I can find it here. Here it is. Well, just open it. Crap. Here it is. And there was something successful at 1:44 p.m. I think there's UTC going on, so it's a different time, but this is what we just did. And you will see, here's the revisions. This was the deploy we just did. So something happened. I can't find what I'm really looking for right now, but as I hope there's more extra things after the test. So, well, that's all I did. I changed it. I committed it, I ran it in body, and it's changed on service. You've got this server, so the 102. I don't know if you got the other one running. Here's the 101, and it's here too. So that's it. Now it's on multiple servers, and well, I haven't really showed it, but there's multiple databases running there. It's multiple. There's a shared file system. So when this server gets busy, it will, this setup gets busy, it will extend to a maximum of 6 servers. Well, I think that's cool. I don't know about you, but I think it's cool. I'm not done yet. The site is open. Those two things, I think everybody knows what that is. You can log in, /admin, log in, and upload some pictures. Check out if they're on both servers. I bet they're on both servers now. So everybody, of course, wants to know what does this thing cost, because it's cool, and cool things always cost money. I've had this setup running for a few weeks now to get a feel for how much it is going to cost. And I'm talking about a feel for how much it's going to cost, because this is one of the big issues with AWS. You never know how much it's going to cost, because one day you have a lot of traffic, and the other day there's not much traffic, so more servers, less servers. Load balancer busy, you pay a lot for the load balancer. But with this setup running with nothing to do, it's going to cost about $3 a day. Well, it's $90 a month. And that is, for a simple server with only 1 gigabyte of memory and 1 CPU, it's steep. But this whole setup has multiple database servers. There's a load balancing running there. And is this readable? I think so. This is the daily cost for the relevant services at AWS. What you see is that the database is costing about $2 and a bit more each day. There's the ELB. The ELB is, maybe I should just put it in presenting mode, that helps. Well, so better. Well, the cost, this is the cost each day, and you see where it's going. And you see that the instances is only costing 27 cents a day, which is not much. But all the other services around it you need is costing a lot more, especially the load balancer, which was a surprise for me, and the relational database. Well, you have multiple servers running for that, and there's management stuff running on there from AWS, so that's the one of costing a lot more. Pros. Well,
what are the pros of running stuff or SilverStripe on AWS? The main thing for me is that it has the possibility for easy scaling up and down servers without human intervention. You don't need, say, me to add servers. And it scales them down, so if those servers aren't needed anymore, they're gone. This also means that if a server for some reason dies, AWS will create a new one for you. So if an AC, an availability zone goes down for some reason, the other availability zones will pick up the slack and it will still keep running. The load balancer is running all over. The load balancer is something that is, I think, running in the region. So, and if a region goes down, well, that's the end of a region AWS. It sometimes happens, but no. And one of the things I like about AWS right now is that those EFS and RDS, it's sort of simple things, but a shared file system, NFS is, I've tried it a few times, but I haven't got it running a good way, NFS, on multiple servers. And it's such an important service that for me it's a simple thing, but this is the killer thing for AWS. A database you can figure stuff out with, but the NFS is really needed for something like this. And RDS, it's the managed database and scalable. It's a great service, and they've got a type Aurora which sort of behaves like a MySQL, but I don't know for sure if there's really MySQL underneath it. But it's a great service, and it also makes lots of snapshots. So if something happens, it can really easily start a new server with the whole database running, and you can even do a snapshot just before you're going to do a deploy. It's easy and cheap snapshots. And when running on AWS, you get access to all those possible interesting extra services because you're already running on AWS and you're in the infrastructure, and you can start maybe using text-to-speech, or S3 is an interesting one, or SNS for queue and signaling, and there's lots of interesting services there. If you need them, I think it's a pro. There's some cons, of course. It's not easy to get started. I've been on and off this for about half a year, and in total I think I spent about 3 full-time weeks on this by creating the stuff, removing the stuff, reading some stuff. It's a lot of work, and I sort of know what I'm doing. So if you're going to do this, you probably will need somebody who already has done this a few times and knows what he's talking about. And one of the reasons for that is there's loads and loads of choices. You don't just spin up a server on AWS. There's servers for CPU intensive, for memory, for I/O, there's for GPUs, and in those versions there's, I think, those types, there's 10 versions where you can choose of, and then there's the disks where choices, everywhere choices. So that's one of the cons, and your workflow is going to change because your servers are just something AWS is managing, so you can't get really easy access to your code anymore and to the database. Of course, you can do some stuff. To get access, but it's going to change your workflow. Can be a good thing, maybe not. Sort of the same thing as what I just said about the servers. If you want I/O, and a lot of servers want I/O. When I first tried UpCloud, the first thing Lars noticed was the servers were way more faster than where we hosted them before. One of the things is UpCloud has lots of I/O, and you notice it, even for SilverStripe sites, but also for especially databases. I/O is nice, and AWS doesn't give you by default a lot of I/O. Of course, you can get I/O, but it's going to cost you. And pricing, it's a puzzle, but yeah, well, everybody knows the story about the company who got an AWS bill, had to use a program to figure out why they are going to pay $1,000 for I don't know what. So it's a puzzle. That's an issue. Why would you want to run SilverStripe on AWS? It depends. It's always the only answer you can give. But it depends. If you want zero downtime, really zero downtime on your websites or applications, then maybe, probably AWS is an option. For a lot of other things, I'm not sure. I would still choose UpCloud. The same setup is about $60 or $20 to $60 there. So my conclusion is only when you need it. But it's there, and it's good to know that it's there. And well, so that's sort of my conclusion. And I'm at the end of my presentation. So, is there any questions? Are there any questions?
Hi. What do you do for session management if you have multiple SilverStripe instances running?
At this moment, as I have set it up right now, it's just PHP session files on the local server. The load balancer is configured as with the cookie, sticky cookie. So when you go to it, that's why I had to open a different the private window, because there's a sticky cookie somewhere. Another thing you can do, of course, there's AWS cache, which is a Redis, and you can push them into Redis. You can configure somewhere in PHP to not create those things on disk, but put them in a Redis, and of course you can make that Redis high available. So, well, that's a solution for your sessions.
Any more questions for Derk?
Once you have some setup running, part of the cost is also maintenance. System maintenance, of course. What is this comparable? A setup like this, is it comparable to managing a single VPS? Like
No. This is not a single VPS. This is not a VPS. This is an infrastructure you created for one application. You don't run multiple websites on these kinds of servers. You can, but you're going to make your life a hell probably, because this is for one application that you want to keep online forever, or for as long as possible. It's not comparable to a VPS. In the end, there is, of course, there's VMs running there. And it's an OS with PHP and Apache or Nginx or whatever running in there. So that's comparable to a VPS. But the whole thing of you put the networks and the load balancers, and when you add a server, there's a check if the server is responding to requests, so the load balancer can add it, so the visitors don't get a server that's just starting. So there's a VPS somewhere in there, but the VPS is one of the least interesting things of the whole thing.
Yeah, I understand, but say you have this running, like would you still have to maintain the file, like the operating system on every node, or on what parts would you have to?
Yeah, of course there's still maintenance and there's monitoring. You still want to know if one PHP is doing something weird, and of course one VM is running on one server which can go down or can do some weird stuff. So you have to monitor is this thing healthy. You can do some health checks, which AWS checks, and if you tell AWS this thing isn't healthy anymore, then it will toss it away and start a new one.
And if, say, there's something like a security patching in the operating system that you're running on,
what you can do, what I did is, I told you about the Puppet thing, and the trick I did to get it up and running in 1 minute is not start Puppet on each on each new server. What I did is I created one server, and when it was done with all the Puppet thing, I created a template of it, and I changed my Terraform configuration and pointed that to the new template. And the next servers will start from the new template. And you can do the same thing, of course. You can maybe get one server out of the cluster, update it, and make a new template out of it, and then start killing servers and let AWS restart new servers from the new template.
Okay.
Which is also a very nice feature of the Autoscale group, is that you can kill servers in the group, and it will. And you can change the configuration of the Autoscale. and with that, it will create the new servers will run on the new configuration, but the old servers are still running on the old configuration.
Thanks. Lars, can I have one more question?
There's here a question.
I'll wait.
So you said you're using RDS as a managed database service. I would like to know how to connect to that from a SilverStripe perspective. Can you just paste a full ARN in the environment file, or how to accomplish that?
Of course, I did some tricks. I'll show you. Where is it? Here. This is the user data. This is the file that gets started with each new server. A lot of stuff is happening here. Is a file I create, or I create an .n file because this is specifically created for SilverStripe. I can put some SilverStripe stuff in there, and you see some variables here. Those are variables that come in from Terraform. Terraform creates a database cluster. With the creation, it adds MySQL. It gets a host name, it gets a username and password, and I push those into this file. Okay. And with this, there's a dependency for the database has to be created first before this file is created. But this file is on each server, and each time the server starts, this file gets created based on. And if for some reason you change it, then well, this is the way it works. And if you look really good, it isn't going to the site directory. It's going to a private directory. I think my customers know the private directory, and some stuff is in there. And I think these are the AWS CodeDeploy files. I don't know if I can make it bigger. This is the one. Yeah, here. This is one after install. What it's doing is, if there's a site, remove the site directory, do some. Normally, it copies the zip file to this directory and change it to the deployment ID. Do some stuff with the site. And here, I copy the env file to the site env file, and that's how the database configuration gets into SilverStripe.
Okay, since I don't know Terraform, is it just triggering the database build on AWS, or is it some kind of proxy that you can take the link off and put in your configuration?
Terraform, or?
Yeah.
Terraform is, it's one of those nice tools from HashiCorp, like Vagrant and Packer and Fold. It's how do you describe it? It combines API calls for different tools like AWS, Google, Azure, UpCloud has a thing, has a configuration in there. And what you do is you define stuff. For example, the EFS. This is EFS. I want an EFS file system with some name. I need some mount targets, and those need to be in a VPC, which is the network part, and it creates a sort of a tree of whatever it's going to create, and it knows which API calls it should call on AWS, and on Google, and on Cloudflare, or on UpCloud, or wherever, and that's what it does. That's what you saw when it ran here, somewhere. Well. It's just checking if is everything there, and it changed a bit here. This is modifying, so this is an API call. And the nice thing about Terraform, of course, AWS has its own version of it. I don't know what it is, but they have something, but it's only for AWS. Terraform works on all those things, and you can combine stuff from say, you may create a new load balancer in AWS. You get a DNS key, or you get the name of it, and you can use it in Cloudflare in the same thing. Or you can create some stuff in AWS and use it in, whatever.
Okay, all right, thanks.
It's a long, kind of going over time, but we can do We could do one question, I think. Are you okay with a couple minutes? Great.
Let them talk, let them talk.
Maybe it's completely unrelated. Can you say anything about how this would compare to using Google infrastructure?
Sorry?
Can you say anything about how this would compare to using Google infrastructure instead of?
It's probably the same.
Probably the same.
Okay. AWS is way better than Google. I think from what I don't have done a lot with Google or Azure. In the end, it's sort of the same. It's VMs and you put stuff on there. But AWS has its focus on probably doing a lot of everything. Google is more on the data analytics thing. Azure is Microsoft, so it's doing Microsoft stuff. So there's a lot of Linux running there, but it's sort of the same thing. Whatever I've done here can be done on Google and on AWS and probably on OVH, and there's a lot Aruba, and there's loads of things with it. But AWS is I think a few years ahead of what they're doing with Google. They're adding services and tools each year. They're adding more. So last year, or I don't know, but they started with 2, and then they added 5, and now I think last year they added 30 extra services. I don't know if I said it, but there's Alexa text to speech, so you can let it talk like the Alexa thing. You can buy with a very good speech thing. That's an AWS thing. So it's just building and building and building. So I would go AWS, it's standard.
Thanks.
No more? I have one last question.
Of course,
Am I right in concluding that if you don't have a DevOps operation in your development team, or you have the money to hire a guy like you advise to not touch this with a 10-foot pole?
You can play with it, but I don't...
Play with it, yeah.
You can play with it, but I wouldn't set something like this up, deploy a production site on it and go on a vacation. Or...
Okay. Or have a guy like you in the back burner.
Yeah,
right.
I go on vacation sometimes, but I'll pick up the phone, so... sorry.
Thank you, Derk. Let's give a hand to Derk.